Okay, welcome everyone. My name is Felix Wyss. I work for Genesis in AI research. And I was asked to do a talk here on beginners, Python beginners. So that's always a little difficult to pick something that's, well, is it simple but not simplistic, maybe interesting? And so I thought, well, one of the challenges that we often have in particular in research is trying things. In particular, specifically, say I want to try some tool or library from a Jupyter Notebook. And so I see something on GitHub, or I find it, or I search it, and I might have to build it from source. Or I want to build it from source for numerous reasons. Maybe I want to experiment, I want to try different versions or different parameters. It might be for Linux, but I'm on a Mac or even on Windows. It might require a complex tool chain, or it may require a specific tool-chain version that I don't have on my machine, and I might not be familiar with it, so I'm likely something will go wrong along the way, and I definitely do not want to mess up my machine. So simply installing something off the web, not a good idea. So how do we solve this? Obviously, no surprise, probably Python is involved, but of course Docker specifically. And so Docker obviously is perfect for isolation and experimenting, and Python is perfect for probably almost everything else, but specifically in this case, kind of as a glue to script. So the idea here is I'll take a tool, a library, whatever, I install it on Docker, I mess around until it kind of works, so sufficiently for what I need. Then I'll add a simple REST API to it with Flask, and then I can call it from, specifically in my case, we always use Jupyter Notebook, but it could be pretty much from anything. And so obviously the advantages, it is isolation and abstraction. The client doesn't even have to be Python, obviously, it can be anything. You can run the container local for testing, and then you can take it as is and run it from the cloud. You can access it from your machine if you need more horsepower in the cloud. And of course, you can experiment, you can retry, you can mess it up. It's completely reproducible and versionable because, again, with Docker files and scripting, etc. So this kind of gives a brief introduction. And now I have a little demo. Kind of as an introduction of, this actually came out of a little side project where I wanted to be able to, from a Jupyter Notebook, do OCR. So I have an image from a little project that I've been working for someone, and I wanted to take the extracted images and OCR them. And so I found a tool called Tesseract. It's an open source library. I'm going to go here first. It's an open source library from that started out as an HP project, and it was open sourced and continued by Google. It's actually pretty sophisticated and works great, but of course it's very complex to install and build. But there are deployed packages around. But again, I didn't want to just install it, and in particular not mess around on the Mac. And so I really just needed something working. And it wasn't needed for production, obviously, just quick and dirty. And so I said, well, I installed it in a Docker container, and then I actually run it from a Python script, which I have here, very simple, with Flask. Yeah, set up a route, and then simply take the image that comes in, extract it, and then fork out the sub-process. So basically run the actual command line version of the tool, not even bother with any kind of interfaces or interfacing the library, And then the result, the OCR result, comes back on the standard out. I capture that, and then return a JSON document that basically contains errors or standard out as it's captured by Python. Return that and be done. So as you can see, I mean, it's the simplicity. It can't really go any simpler. Is it robust? Probably not. Does it have to be? No. It's, again, if we need to worry about it later, if we need to make it more complex, or if there is any, if we need to worry about resource utilization, et cetera, again, keep it simple and stupid. So now we can look at a Docker file. Again, similarly simple. Just starting out with a Ubuntu. Then update it, get the Python installed, install the Tesseract here. Obviously, I just picked the released package. Obviously, again, one option here would be to actually get the source, build it, if you need specific parameters. Oh, that's unfortunate. Why is this not showing up? Maybe I need to exit the slideshow. Oh, sorry about that. Thank you for mentioning. Let me go back to the, I hope I have enough time, but briefly show the actual, yeah, that's what you guys wanted to see, right? Should have spoken up earlier. Anyway, yeah, so really simple. Again, set up a route, capture the image, feed it into the sub-processes, on standard in, standard out, capture it, return it, be done with it. And again, you can see I'm just run the Flask itself, which of course you're not supposed to do in production. Again, not production quality code, use at your own risk. And again, here, so Docker file, very simple again. One difference here is that I'm explicitly wanted to get the very latest and best models that they have on their GitHub page, and again, set up, expose port, run it, be done with it. Very simple. So here, obviously, I already built the Docker container. I could certainly show that, but that's not really all that interesting. But we can, for example, talk to it here. Have a health check, which is always useful no matter what, because then you can see whether it's actually working. So 80/80, we can see you talk to it. Oh. It responds, so it's up. Now let's switch to, and again, if you can see here also Docker PS, obviously it's running. Anybody knows Docker? This is 101 type stuff. Now let's try to actually use this little service. So here I have a Jupyter Notebook. So first I kind of wrote a very, very simple helper function that takes an image as a NumPy array. It saves it into a stream as a PNG, and then it uses the requests library to post that to our service. I think it's a little too content type PNG, and it captures, when it comes back with success, it captures the body and just simply returns the text that was recognized. And again, not really any error handling to speak of here, because it'll be obvious. Again, it's an interactive notebook. So let's run this here. So we here load a test image. This is actually an image that I took the text of the web page for this event, printed it out, took a photo with the iPhone, so I deliberately kind of making it a little less than perfect. And so now we invoke the service, print the result, and as you can see, it's actually pretty much perfect. I didn't really see any error, except it didn't get the formatting quite right here, but I mean, that's really benign. Okay, not bad. So now, what if the image is not quite straight? Right, like this. So this is another one. This, you see here. Obviously, that didn't work quite as well. So, of course, now, again, that's where it starts to actually get a little interesting. So can we estimate the rotation angle and then fix the image and run it again? So here I use a very, very simple approach. First, to kind of plot the histogram to see what's the big distribution. We expect, obviously, a lot of values in the high hundreds, because there's, again, white being 255, black being 0, so all the text is somewhere down here, all the white is somewhere up here. So just pick something and threshold the image. So here I just picked 64. So we have so that way we just have the black and and of course technically you can see here it actually returns true, or it creates an NumPy array of true or false. But then I invert it so that the text is black again. So we have an array with true where the pixel is set in the text and false where it's not. So now we create an array of coordinates that contains a tuple of the coordinates of where a pixel is set. Because what we want to do is we want to use a really nifty function in the OpenCV library that, given a list of pixels, or again, tuple of coordinates, it gives us the minimum bounding box for that cloud of pixels. So we can see here, it gives us a minimum bounding box, but what's the really interesting value is this one here. That's the angle by which the bounding box is rotated. And we can see that if we overlay that over the original image, it actually nicely found the overlay or the angle of that text. So now the rotation angle is actually because it's rotated by 90 degrees, and we always need to rotate in the other way. So here we see we need to rotate the image by 6.5-ish degrees. We'll do this here. So it looks reasonably nice now. And let's OCR that. And as we can see, now it's perfect. Now, obviously, again, thank you. Now, obviously, again, this is very simplistic again, because we have numerous problems here. First of all, what if the text is rotated by more than 45 degrees? So there is now ambiguity. If it's severely warped, obviously, then you also would want to unwarp it. If there is other artifacts on the image that would cause, say, like dirt or specks or whatever, that cause this bounding box to not be properly recognized. But there are obviously numerous ways to do that, for example, or to fix a lot of that with image processing. Some of it obviously doing like dilation and erosion to try and get rid of any kind of spurious artifacts in order to detect whether obviously, because we know that text tends to be in one particular direction, we could use some kind of, say, dilation and then a how transform to identify where we have straightish features in the image. So there's numerous techniques, but again, too complex to get into here now. So I think it's something related to beginners, I think. Anyway, so this was a very brief intro and demo. I hope you learned something, and I'll be open to any questions.